Hello everyone. Right, I think I've got you for about an hour and 20 minutes. Actually, the second time I've had the privilege of speaking here. The first time I came here, my daughter called me on the way out, Emma, and she said, "What are you doing today, Dad?" I said, "I'm doing a big presentation." She said, "Do you get nervous?" I said, "I always get nervous." She went, "How long are you talking for?" An hour and 10, hour and 20 minutes. Emma's reply, "Sucks to be them, Dad." So, I'm going to bend the rules a bit. I know Tom said no questions until the end, but you can ask questions. We've got enough time. So get stuck in. There's no silly questions, right? It's a new technology. We're all here to learn about it. And I know there's a lot of business, there's all sorts of people out here, right? But understanding some of the foundational concepts is really important because you're being sold to right now, and there's an awful lot of hype out there. So understanding some of those things is just going to help you determine what's nonsense and what's real. So, if we just reflect a minute on the hype, right, on the hype. It's been about, well, it's just over 2 years now, right, since the LLM comet crash landed, and it did crash land, and the hype has been utterly relentless, hasn't it? If you go on LinkedIn, every day there's a new acronym, there's a new something, right? And if we go back to the beginning, there's two little things that I always remember. There was a very big consultancy that remained nameless that said that by the end of 2024, 70% of all your business operations will be automated with AI. That's not really happened, has it? And another one I want you to remember, and this actually kind of underpins the talk really, is people saying that you're just going to throw all of your enterprise or all of your data at a language model. Hands up, who remembers that kind of thing being said? Come on, don't be shy. That's what the message was, right? You're just going to get all your enterprise data and you're just going to pour it into this language model. And you're going to have your very own Holly from Red Dwarf. Right? And it didn't really go like that. But when these language models kind of crash landed, we did what we do as techies. We raced out, we got some models and we tipped them out on the desk and we started to experiment with them. And really the question we was trying to answer was, how do you use these safely within business? Right? Because safety is really important. So we did that, and then I remember catching up with the boss, you heard earlier, Steve, in the office. Steve's a real detail man, right? So we're in the hack zone, and we start to sketch out some of these considerations and things you need to think about on a whiteboard. It's got a big telly in it. It's not as big as this telly in the hack zone, but we start sketching this out. And broadly speaking, all of these considerations, and you'll hear about them in a bit more detail, but they all sit beneath two headlines: explainability and safety. Because in business, when we make business decisions, we can explain why we made them. But so if we're going to divest some of our decision making, we have to be able to explain it. It's in fact even more important. So explainability must underpin your use of this technology. And then there's safety. We have the protectors of the realm, I like to call them. DPOs, IT security, compliance, legal. They're there to stop you doing the business harm, right? So it's more important than ever if we're going to start to use this technology. We need to really engage with those people, but we need to think, how do we safely use this technology, right? It's really, really key. So they're the two things, right? And if we roll forward, we've now got incredibly lofty statements around agentic AI, right? Since Christmas, it has been relentless. Agentic AI, right? You're going to completely automate your entire business operations with agentic AI, right? Well, we'll dispel some of that hype and myth, but it is a great technology, agentic AI, but we try and contextualise it a bit. So I'm going to talk about how we operationalise kind of generative AI. I'm going to do it through kind of 3 scenarios, and we'll start out with something I call simple information retrieval. What is that, Paul? It's just search, right? We search for stuff every day, don't we? We go and find a piece of data, or we find a document or a collection of documents, and we might want to get some facts out of those documents to help us put an email together. We might be doing a spreadsheet. We might just need a summary of it. Without Gen AI, what would we do? We would read those documents, or we manually maybe Control F, search through that Word document, start cutting and pasting stuff out, right? AI can help us with those simple information retrieval tasks, right? Coupled with good search, we can accelerate that. It's a really simple starting point, right? Everyone understands it. It's easy to do things like citation and explainability as well. Now I'm going to do a little demo of that at the end. Promise it won't be salesy. There's plenty of salespeople here if you want to talk to salespeople. I'm not one of them. But what I want to do first of all is just talk about a couple of concepts. Not too technical, but they're really important to understand, right? So the first one is model memory versus RAG, retrieval augmented generation. Who's heard that term, retrieval augmented generation? Lots of you, good, right? We used to call it open book and closed book, but language models bring two things to the table, right? And today we're talking about language models that generate text. It'd be a too big a session if we get into images and video, just text, right? Language models bring two things to the table. They bring knowledge and the ability to create coherent text and a coherent output, right? We sometimes call that inference. So with model memory, when we're engaging a language model, just the language model, we're using its stored memory, its knowledge. And interestingly, that knowledge isn't actually the primary objective of training these models. The primary objective is to understand language, to create coherent output. We get that answer back from the model's memory. And as we talk through this, we'll see, as we go through some of these kind of concepts and considerations, you'll see that using model memory can be a challenge on enterprise data. Now then you've got RAG. So casting your mind back at the beginning, remember the hype, right? You're just going to chuck all your data into this big super language model, right? The alternative that started to emerge was something called retrieval augmented generation. Put really simply, that is doing a search first, finding some relevant information, and then passing that to the model and asking the model to use that knowledge. So it's a bit like me giving you my favourite book and asking you to summarise chapter 2. I'm giving you corporate knowledge for it to work. So it means I can use off-the-shelf models, very, very big models, but I can guardrail them in to a small set of data. And as you'll see through this talk, it makes a whole bunch of things easier around citation security and whatnot, and we'll touch on those. So tokens, right? A quick bit on tokens. I won't spend ages on this. Tokens, they're just word and word pieces. The reason why I'm mentioning tokens is they are the currency of language models, right? They're the currency of language models. And you'll get charged in terms of tokens. You'll get charged for input tokens and output tokens. And you'll see that different models have different token sizes, right? You'll be throttled if using public models in terms of the number of tokens they will generate. But that's all you really need to understand. You'll hear the word tokens. It really just means the word and word pieces, and importantly, kind of how you're kind of charged for them. The next one is context sizes, right? So what context size is how much stuff you can give a model and how much stuff it can generate. When we started a couple of years back, context sizes were 2,000 to 4,000 tokens, right? Which is like, I don't know, 2,500 words, right? Something like that, because there isn't an exact match between tokens to words. Roll forward, we then had things like GPT-4, took it to 128,000 tokens. GPT-4 4.1 the other week took it to 1 million, and then Mark Zuckerberg took it to 10 million with Llama 4. The important thing to understand here is just because you can give these models masses of information doesn't mean that's a good idea, right? Because they hallucinate more the more information you give them. And that's because they're based on something called self-attention. And I'm not going to bore you all, but I will tell you, if you're a bit of a geek, or you're watching a box set with your partner that you're not into, go and get The Attention Is All You Need paper. It was a seminal paper written in 2018 that basically come up with an algorithm that enabled us to leap forward and understand enormous bodies of text, right? And in particular, understand the relationship between words. That's why language models can create long bodies of text that are coherent, right? But within that long body of text, there might be hallucinations. And the more context you use, the harder work, or you make the life harder for the model, and the higher propensity you have for hallucinations, right? So less can be more. So thinking, and we'll talk about this later, doing search and shrinking the world down. You'll hear us talk a lot about your entire data picture. Actually, when you want to get an answer, you want the smallest amount of data possible to give you that answer, right, from language models. Training. Back in the beginning, there was a lot of hype about training your own models and stuff like that, and it still applies in some scenarios. There are still scenarios where you may want to train your own models, right? And in particular, we're talking specifically here about generative AI, which is its own branch, but things like classification models and things like that, you'd always train yourself, right, as the customer. But basically, the way training works, just a quick 101, you start out by training a base model, and you train base models on the internet, the whole of the internet, right? Lots of junk, lots of good stuff. Hopefully some of it's curated, but we train them on trillions and trillions of tokens. Would anyone like to hazard a guess how much it costs to the nearest 10 million to train a language model? Anyone? There are hundreds of millions of pounds to train. Really, really expensive, enormous investments, and it takes an awful long time. Yeah, that's why we're not seeing new models coming out all the time, left, right, and centre. They're hard. Now, once you've got that base models on their own are useless, really. They just will continue text. If you start typing some text in, they just continue. So we then fine-tune them to create the models that we will use, chat models, classification models, right? That isn't as expensive, but the challenge with that is you need to curate all of your business data into prompt value pairs, value training data. That's an enormous operation in itself, right? Taking your data and converting that. And then making sure the data quality is high enough. So that's another challenge. And then you've got something called transfer learning at the end, which is pretty similar, but just a slightly faster version. But still, you need to be able to prepare your data if you're going to go down that route of training models. Stupid bottle tops that you now get with them, it's just ridiculous, man. Innovation. Knowledge cut-off, right? So knowledge cut-off is really simple. Models are trained on a set of data. A set of data will be curated, fed into the machine. They will then only have knowledge up until that cut-off. And if you look online, you'll see the cut-off of various different models, Claude, OpenAI, Gemini, etc. I think the 4.1 model was summer 2024 or something like that, the GPT model. But knowledge cut-off. Now, because these models take so long to train, even if you train some of your own models, right, bearing in mind that information, your business data is highly volatile, right? You can't do it every night. You're going to have a knowledge cut-off. Yeah, so it makes them hard to use. Fine-tune models become hard to use within an organisation because you can't keep up, right? So you're going to have this gap. So it's good for things like you might fine-tune a model on your HR policy book or something like that. But on high-velocity business data, it becomes a real challenge. Model selection. So model selection is something else to consider. A lot of people I spoke to at the beginning of this hype were just saying, well, we're just going to use GPT-4. We're just going to use GPT-4, right? That was 10 times as expensive as GPT 3.5, right? And 3.5 will give you more than adequate output for things like fact extraction and summarisation. Yeah. So that is a real consideration. And now you've got even more models to choose from. You've got Claude, you've got Gemini, you've got all sorts of stuff, and then you've got the private models that you can run, Llama models, right? So model selection. And you might, as a strategy, come up with a strategy where you use some on-prem models, private models, like Llama models, where the cost is more controllable, right? Especially for background processes. And then maybe the online models as well, if you're able to use those. But it's important, they vary wildly with cost. And it's interesting as well, I'll drop this one in now, you know, hallucination, you've all heard of hallucination. Absolutely everyone put your hand up. You've all heard of hallucination, right? Yeah. So hallucination is still a problem. And I hate to drop this one, the people who paid all the hype are not going to like this. For some of the bigger models, it's getting worse. 03 and 04, it's getting a lot worse. So there's a lot of work being done behind the scenes to improve that. So bigger models are not necessarily better, right? And the price difference between the new reasoning models over it is enormous compared to the other types of models that aren't reasoning models. So it's just something to bear in mind, right, when you're thinking about using this tech. So a quick demo to bring it to life. Non-salesy demo, right. Is it going to work? Who knows? Right, let's go back to search. So this is our Insight app, and I'm going to type that in with. So a really simple starting point, yeah? Just being able to do a search in a system, picking a document. We could look at that document if we wanted with preview. I don't really want to read that whole document, right? Don't want to do that. Instead, jump in. What is this about? So I can just get a quick summary, right? So just giving a quick summary on that, right? So just an easier way of getting information. I could use it for fact extraction and so on. The reason why I'm showing you this, it's just a really simple example of what I would call kind of simple information retrieval. And we could make it a little bit more complex. We might go in and search for Aiimi and Databricks. Let's see what Aimi's done with Databricks. So a few of these results. More. There we go. And we use Claude Sonnet, right? Now Claude Sonnet's quite cool. It's got a thinking mode. You'll hear the words thinking and reasoning. Like these models can reason like a human. That's not really what they can do. But there are mechanisms under the covers that allow them to almost prompt themselves to break tasks down to give you kind of a better outcome, right? So we've enabled thinking mode on Claude Sonnet. This is the 3.7. So there you are. So it's thinking. You can see it's doing some thinking. So ramble along, and it gives us an answer, right? So you can then look at the rationale, some of the rationale that it used to get to that answer, right? And so it's used thinking and reasoning models. They're a little bit more expensive to use because you have to pay for the reasoning and thinking tokens as well, but there are times when they are kind of worth using, right? So what you've seen there is doing a search, bringing back some results. What we now look at is a way of collapsing that into a single step. So we jump into this chatbot, and tell me about what Aiimi have done with Databricks. Please create a summary for each customer. So we run that. Now what this is going to do is do the search for me. So I'm not going to do that. It's going to pull back some results, and it's now going to create me the summary that I kind of want. So what that's allowed me to do is just make it into a much more simple user experience, right? I can just go in and I can now just interact with my information, data and documents, yeah, with just a single question. And I could go in and I can look at the results, available results, and I can start to do things like citations, so digital twin, is that true, verify, there we go. And I can go and look at, we'll look at that, show preview, and there we go, digital twin, it is indeed there, right? So you get some citation, we'll talk a little bit more about that later. But that essentially is more of a chatbot experience. Now what I think is really interesting with this, sorry, 1 second. Beginning. Ooh. Changing role user interface. There we are. Right. So let's start to think about some of the impact that AI and generative AI may have on the role of the UI. Right. We build user interface to bridge the gap between humans and computers. We build user interface like, collection forms, collecting data, to bridge the gap and drive things like workflows. Yeah? We now have a technology that can interpret some user intent, can engage in a natural language, potentially with voice, and capture that data and drive process in a different way. Yeah? We're going to build less UI. We're definitely going to build less UI. It's not such a bad thing because UI is expensive to build and it takes you a long time. And it ties you in and ties your processes in to a predefined, rigid kind of flow or structure. We have a way now of making it more fluid, right? And I think it's one of the more exciting, well, one of the really exciting things with generative AI. Yes, it can answer your questions and stuff like that, but it can also serve as a way to collect and drive process. With the right human oversight, we'll talk about that later, but it really does challenge the way we think about the way humans interface with computers. So, complex information retrieval. We'll touch on that. So we talked about simple. What's complex, right? It's just where you're going to do lots and lots of searches to find a collection of information. Perhaps you're doing a disclosure for a legal process. Perhaps you're doing a subject access request. Perhaps you're doing some deep research to work out the best way to build a pressure vessel for a new nuclear reactor, something like that. And perhaps you've got to demonstrate that you've followed all relevant good practice, right? So in that scenario, you do lots and lots of searches. You perhaps build this thing, perhaps you build a collection of that information, and then you might disclose that information, right, or use it, right? But it's characterised by a process that takes quite a long time to do, right? Again, this is something that AI can really help accelerate and improve accuracy as well. We're not good as humans at doing really repetitive tasks. If you're a legal person and you've got to sift through 1,000 documents to work out whether they relate to a case, AI is probably it's not going to be perfect, it may make mistakes, but I'm willing to bet that humans in that context will make more, right? And the cost saving could be huge, automating some of those. So the first thing I'll talk about is information retrieval and search, right? So, search. You've got things like keyword search, you'll all be familiar with that, right? You just bang in some keywords, it pulls some stuff back, things like BM25 and what have you. Really good for searches when you're looking for things that might satisfy, like a SAR or a DSAR, you know, pool maker, my national insurance number, and an email address, yeah? But you've now got much more sophisticated search algorithms that help us find information in more of a natural language type scenario. And they tend to get called kind of semantic search and vector search. You'll hear those words, right? Now, I'm not going to go on and on about what dense vectors are and sparse vectors. I'm sure you're pleased about that, right? But it does give you a different way of finding information, and these algorithms, semantic search, things like that, can handle things like vocabulary mismatch. So if you're searching for something, we're using slightly different terminology, you can bring back the right information. But what's also really important with information and search, right? If you're going to go down the route of being able to index all your information, right? So you've got a massive amount of information you've got an index, right? You pull that in, so you've got a lot of data. You need at the same time now to be able to shrink that world down. Go back to what I was saying about context sizes and stuff like that, right? You've got to be able to shrink the world down, yeah? To get to a smaller set of relevant information to pass to a model to give you an accurate answer, yeah? So search becomes really important, and it's interesting because most organisations have kind of tried the enterprise search thing over the years, right? Well, you've all tried it, hands up. If you've tried, you know, at some point organisations have done enterprise search things, right? It really is a time to start thinking about how you properly nail that. And now let's say you pull in the entire data picture, because from an explainability perspective, right, you do need to have considered all candidate information if you're going to use AI to help make decisions, or you're going to divest some of that decision making, yeah? So information retrieval. Classification is a big topic, right? It's definitely somewhere, or an area where you'll train your own models. Classification, I often think of it as a super label, a power label, right? What is it? Well, what classification is really simple. It's just labelling your information. So you might label it as HR documents of a given type, grievance letter, promotional letter, paper, so on and so forth. Or it might be invoices, etc. Or it might be different security markings that are on documents rather, and data. But they're really, really important classifications because they act as a really nice way to dramatically shrink the world down based on things like user persona, right? You can, and you can do things like you can cut all the rot out, yeah? So you can do a search and just bring back things that have a legit classification. Ignore all the rot, it's probably half of your data, right? So you're helping a language model. So classification becomes a really important thing. There's a really good driver to do classification. And that's cool also, right? Because the protectors of the realm, they're going to love you if you go and do that, right? Because you're contributing to the whole compliance challenge at the same time. Because compliance, there's a lot of aspects of that hinge off of understanding your data. Yeah? So classification is really important. It's a big activity. There are technologies that can help accelerate classification, such as clustering. You can go and use technology to automatically group stuff, and then you can build models off the back of that, right? They become valuable IP for the customer in question. Because the thing with classification, prior to that idea around using clustering, i.e. a technology to bootstrap the process, the reason why a lot of classification projects failed is you had to do all that labelling and building those training buckets manually. You would remember that, right? You know, no one's going to do that. It's really the Achilles heel of classification. And that's moved on now. We have technology to accelerate that and make it really, really easy, or really, really easy. There's still some human involvement, but it accelerates it significantly. Security, this one's massive. Don't worry, I won't be talking about it for ages, but it's super important, right? One problem, big problem, probably the biggest problem that we uncovered pretty quickly when we started looking at these language models in the context of business, is how to enforce security. All of your enterprise data will have labels, access control lists on it, right? Controlling what you can see. Often, as Steve said earlier, it's like it's locked down too much, right? But nonetheless, it's really important that they're because it controls who can see what. And then we have other labels like top secret and other types of labels we put on things to then also provide another dimension to security. Yeah. Now, if we're going to fine-tune models, the fine-tuning process just takes your data and pours all that, organises it into valid prompt response pairs. I talked about that earlier, big process in itself, but it then gets poured in. And the crucial bit to understand is you lose really any bearing from the ACLs of the facts to the information you're pouring in. So that means if you're using model memory, just asking the model, you can't apply access control anymore to those facts that come in. So you're going to have to make sure those models are, everyone that uses the model is going to have access to it. So perhaps if you're building a research model for in the medical field, it might work, right? But for general purpose enterprise building of models, it kind of doesn't. And so with retrieval augmented generation, that problem's solved really easily because you have this information discovery step at the beginning. And of course that applies all of your access control and permission trimming. So you only pull back all of the information that you legitimately can see, right? So you shrink the world down. So now what we've done is you've shrunk the world down with classifications, brilliant, perhaps some other filters and labels as well, great. And we've also shrunk the world down by reducing it to only the things that people are meant to see. So we can use the technology much more safely, right? And of course you've got audit that underpins all of that, right? So you can see what documents came back. They were audited against Dave, for example, and we know that Dave pulled those back to answer this specific question, right? It was probably the most profound thing, right? When looking at the hype, you're just going to pour all your data into a language model. It's probably the biggest thing to consider. There's lots of others, but it's a big one, right? Explainability. So it is a massive thing, right? If you're going to start to divest some of your decision making, you need to be able to explain why it is you're making that and where that information comes from, why the model arrived at that conclusion, right? And you saw a quick example of that when I did that demo there, where you can kind of search for facts. That's kind of one example. But what about if you're automating business process? And we'll talk about agentic in a bit. But explainability is really, really crucial, and it needs to be baked in at the very heart of the designs around your deployment of this technology. Right? You need to be able to have audit. You need to be able to go back and look at requests, look at text or information that's been generated. You need to be able to link back to the underlying data that was used. What if that information has changed, right? You need to be able to track all of those things. Because you need to be able to satisfy that angle of explainability. And that leads me to citation, which kind of branches off of explainability. You know, if you're looking at facts that have been given to you by a language model, you need to be able to go back to that source data from where that fact came from. Right? That's really easy if you've provided the information to the model. If I gave Tom my favourite book and I asked him to answer some questions, I can then go and check that. Right, I've got a book. You can't do that, with just a model on its own. You won't know if it's a hallucination. It becomes harder. There are some lateral solutions, like then going searching for the data that you use to train your model, but it's a little bit decoupled, right? And hallucination with models, and this is newsflash, hallucination is a fundamental characteristic of language models. It is not going to go away. You can mitigate it with the sorts of things we're talking about here, but it is at the heart of the way the transformer architecture works. And don't worry, I'm not going to go off on one. Catch me at lunchtime if you're interested, but it's important. So what it means is it goes back to that safe and explainable use, right? Because the benefits far outweigh any of the negatives of technology, but only if used in that explainable and that safe way, right? And you put the safeguards in, you can absolutely exploit it. You need to think about it. Demo time. Right. Any questions so far? No questions yet. Come on, someone ask a question.
I've got one.
Go on, Steve.
You just prompted me on your last point, where you were saying getting answers out of a model. I know you've talked before about using other models to mark homework.
Really?
And
it's a really good strategy, right? You know, and there's been a lot of talk about that. So if you have a language model produce an output, use another language model to verify that output. It's really effective, because something we've observed also with language models, right? Have you ever asked a language model a question and you know the answer's nonsense, and you've said that's nonsense, then it gives you the right answer? You've all done that, right? It's happened, yeah? That is self-attention and probability in action, right? What it's done, it's given you the wrong answer. And the way, just very quickly, we've got time, I won't bore you too much, promise, but language models are left to right, auto-regression models, right? They predict tokens, they predict tokens. And every time it predicts a new token, it reads all the ones it just predicted, yeah? So, token 1, 2, 3, 4, token 5, when it goes to do token 6, it starts again, yeah? It's why there's a bit of a problem with hallucination. What happens, do you think, if you hallucinate early in that token sequence? Wildly off. Right? If it happens further down, less of a problem. So then that's a context size thing again, right? But what we've observed is if it does give you the wrong answer and you challenge it again, because you said that's the wrong answer, you push it towards the right answer, because if you think of that probabilistic connection between tokens. So using language models to face off against each other is a really, really good strategy, right?
I don't know which one's right.
How do you know? Oh, catch me at lunchtime. But yeah, you don't. But then again, that's why this human oversight thing is so important, right? It's so important. It's at the heart, and we'll talk about it, it's at the heart of effective and safe agentic AI. Right? All the hype at the moment is having you believe that you're going to, be an AI-first company that's automated. It's going to be this me just sitting there, like this whole company I'm running, right? We're a long way from that. But it doesn't mean we can't do really good things with the tech, right, in that safe way. So this is a deep research example, really simple. I want to understand and I want to analyse and understand 3 events: who spoke, what topics they spoke about, etc., etc., etc. An AI summit, water industry summit, and where Steve spoke to some government ministers. Right, let's do that. Let's see if it works. Someone's got a break. It's a live demo, right? So what this is going to do, it's going to do a series of searches, mining for information. Yeah, good. There you go. Right, so what it's done is initial search, and it's now going to drill deeper based on the information that's coming back. And it's going to keep going. It's a small data set, there's a little bit of duplication of search results. It can't be too big, otherwise we'd be here all day. But it's going to go through it, it's going to keep going, it's going to find some information, minister speech as well. interestingly, what we're doing here to save on context size, if you're really paying attention, you'll see that little clearing results thing flying by. It's managing the context window to reduce it, chuck stuff out, helping us keep a limit on context size, right? Improves accuracy. There we go. So, jolly good. There you go. Our final at the end talks about the AI summit, the War Industry Summit, and the government event that Aiimi have done with various different events, right? But what I've done there, really simple example of me automating some deep research. Yeah, I've just done a series, and obviously it's really, really simple example, super quick, but you could imagine that running offline, coming back to you later, having then given you some answers. And, as I showed you earlier, we could look at, see what was actually said about the Environment Act. There we go, we can go and jump at some of those things, show some of those citations, so there they are there. Show preview, I can go and kind of look at that. Maybe in there somewhere. Yeah. So that's kind of the deep research. So you could imagine using that to research if you was starting to build a new product. Are you going to take all of that information? Absolutely, you're going to want to verify human in the loop, yeah? But it's going to essentially enable you to begin to automate some of those information. It could be data as well. This is obviously unstructured data that you're seeing here, but it could be data too that you're using it for, right? We're doing some great projects actually at the moment with some manufacturing organisations where we're using this type of technique to accelerate fault diagnosis on machines and things like that, right? And better pricing of bids, etc. Because we can lasso so much information and then whittle it down, right, and start to summarise it. And with the right, as I say, citation, you can go and kind of verify that stuff. So what? Let's see. Agentic AI. Who's heard of agentic AI? It was a joke. Oh my God, the hype on this. And it's not stopped, right? What is agentic AI? It's BPM and its workflow, right? But with some steps in it that use language models to make some more nuanced decisions. And also language models controlling the flow of the process. So imagine we've all seen a workflow map, right? We've all seen a workflow map. So imagine some of the little steps on your workflow map being little little generative AI decision makers there. But then also imagine the Gen AI model helping some of the overall workflow map. I don't know if I've described that particularly well, but hopefully you kind of get me. That's really what agentic AI is. There's an awful lot of hype around it, but fundamentally it's using language models to complete more complex tasks, multi-step tasks. And it goes beyond kind of the deep research thing that I just showed you, which was like an iterative search type thing, and extends out to calling functions, to update data in back-end systems, to fetching data from telemetry systems, all sorts of things, right? Bringing lots more information together, but also acting, right? Performing actions. So where might we use this type of technology, right? You can see automating compliance being a slam dunk for this, right? Humans are really bad at following compliance rules. We create these user interfaces with lots of drop-down lists for classifications and labels, and everyone does that when the system's first deployed, right? They do, but then 6 months down the line, it's a spaghetti mess again, right? So automating compliance is a real area. If you think about classification technology and language models to help drive that process, you can start to see where automating compliance could really land as a really, really good, strong use case to bring you into a much better position as an organisation. Things like subject access requests and legal disclosures as well, where you've got to process mountains of information and build a big collection, right, of stuff. You might need to disclose that stuff, you might need to redact it. But they all bear the same trait, right? That's big, so sitting there for ages searching, right? You can use agentic AI to start to automate some of that and significantly accelerate it. And then planning, and we'll see a little planning demos, a couple of little demos at the end, all planning. But planning may be an incident response, right? Maybe you're a water company, you've had a burst in the Bristol area, and you want to get on the front foot, So you want to go and find all of your near misses, all of your lessons learned, some engineers that are best placed to help, if they're free, of course, those engineers, and they're on scheduled work. Perhaps the equipment you might need to take with you. So you could imagine that incident going on, and then an agentic process going away and doing that research from lots of different systems to give you some insight into perhaps how best to kind of respond to that. Now, a little bit of a technical one, and I won't bore everyone too much with what function calling is, but it's an important thing to understand because there's a lot of misconceptions about it actually. We realised, a year ago I suppose a bit more, that language models could ask us being the application using the language model, to call a function. And that function could then go and do something, right? There's a lot of people out there, if you look at the hype, they seem to think language models call functions directly. They do not, right? All they do is they ask the host of the language model, the thing running the language model, to call a function to do something. So what we do is we create a series of functions, maybe get the current weather for a geopoint, or do a search. That's what was happening then. You see the search is taking place in the demo, that's what's happening, right? Or get me the summary or the aggregate cost of these types of line items, so on and so forth, right? Data functions. All function calling is a language model being given a series of function calls that you make it aware of, and then it can, based on your instruction and some background instruction, what it can do is it can go and execute those functions to collect that data or perform that action. It absolutely underpins, function calling absolutely underpins agentic AI. It's really, really important and it's super cool, right? It's not without fault because you need to think about parameter validation and all this stuff, and that's where I'm going to stop. Happy to chat about it later, and there's mechanisms you can put in place to make sure it's super robust. But function calling means we can start to make language models integrate with your ecosystem across your enterprise. You'll hear the term also, the acronym MC. Who's heard of MCP? Yeah, MCP, right? So it's getting a load of attention at the moment, MCP. People have got way carried away with what it is, right? It's, first of all, it isn't a protocol, it's more of a framework. But it does simplify calling functions. It makes it a bit simpler and so on, right? But function calling was easy in the first place from a technical point of view. So but that's what function calling is, and it's really quite cool and a big enabler. Now, this is super important. If you want to start, so remember what I said about the UI, right? Remember what I said about the UI. The UI is going to change. Yeah, we're going to build less hard-coded user interfaces. Now think about function calling. It's going to mean, subject to human oversight and explainability, but it's going to mean we can start to think about, we hard code business process, don't we, all the time? We've all worked on workflow projects where the workflow's been static. You build it and then it's out of date the minute you deploy it, right? And changes take a long time, but that logic, yeah, we can start to think about how we use language models to drive some of that logic. Right? But we can only do that, yeah, if we really get to good data quality and good data descriptions. Yeah. If we describe our data really, really well, and we have the right data catalogues and master data management, we can start to advertise that. And if we're confident in our data quality, and we've used things like classification to remove the noise and data we don't trust. Often we talk about kite marking data, right? So we trust data. If we think about doing that, we can start to advertise those services to generative AI, and with the right checks and balances and controls, we can start to guide them to work through process. And perhaps, and this is further out, right? There's a lot of hype out there, but perhaps further out, you might be having a conversation at the coffee machine, and then later that afternoon, you're underwriting insurance in a different way, better than your competitors, right? That's further out, right? There's a lot of things that need to be in place to make that safe. But thinking of beyond just generating text, right? He's thinking, what are these other things that language models can help us do? Collect information, help drive process, right? It's really super exciting. I've said so many times now, user oversight and interaction. Yeah. So we're not taking humans out of the loop anytime soon with this technology. We're absolutely not. Right. You need to think about how you involve humans, especially in these more, right from the beginning, simple information retrieval. You saw a simple example of looking up facts, right through to more complex agentic processes, right? What you're also going to have to think about is the ability for these models to come back and ask the user if they are unsure, right? So it isn't just going to be these processes running in the background, yeah? They're going to need to talk back to you, and you're going to need to give them approval to go the next step, where you're going to need to tell them, no, don't go left, go right, if you're unsure, right? So it's really important. It's especially important to have that interaction and oversight, especially before committing data to back-end systems and making changes, right? The planning example that you're saying, you're still going to look through the information that comes back and you're going to make a decision, right? But if you're committing data and changes to back-end systems, you're definitely going to want to be verifying that. I like this slide. Protectors of the realm, right? Techies like me sometimes feel like protectors of the realm get in the way. Super important, right? Really, really important. As I mentioned at the beginning, DPOs, compliance, legal, IT security, more than ever, they need to make sure and help us make sure that we are using this technology in a responsible way. And I saved this until this point, right, in this talk, because it's the agentic AI stuff, right? That has the biggest risk if done badly. Yeah? Needs to be done well. And we need all of those things that I've been talking about in place to make sure that we, as I say, we protect our business from harm. Just some personal experience as well. If you're if you're doing AI, generative AI projects at the moment, as you're going through the design, you're building them, you're going to have to engage with IT security, with lead. You're going to have to do that right throughout that process. What's really important at the moment, and what we've realised and what we're working with our customers, is working out ways of articulating this new technology so everyone around the table is comfortable with it and is willing to underwrite it, right? So awareness and education is becoming also so important, right? Because it's okay for me, I have if it's a luxury or not, sometimes I wake up and look at LinkedIn, I'm like, oh, not more buzzwords, but I've been immersed in this technology, so I don't know everything at all about it, but I know quite a bit about it, right? But how do we educate everyone in the business, from the board right down to people that are protecting the realm, right? So they are comfortable underwriting the use of it, right? It's a real big challenge at the moment. I would actually say it's one of the biggest challenges to kind of adoption, or at least slowing it down. It is. And it's thinking about, was that? Oh, sorry, I thought you put your hand up. First person to ask the question. Should have bought some socks or something. Anyway, so really important. So just think about, understand it, and be able to articulate it, and think about internally, Dave, go on.
I'll give you one.
Go on.
So, we've all been in this situation where you find yourself in the meeting with a protector of the realm.
Yes.
And it's those first statements you make that do make the difference for that meeting.
Absolutely, yeah.
What are some of the simple statements you can make that give that reassurance?
I think what you've got to do, you've got to tackle things like hallucination head on, right? And you've got to think about security as well, is the other one, right? It's security, and we talked on the security slide, right? Shrinking the world down to what you can see. So it's explainability, actually. I would say the explainability and security are probably the two things, right? Yeah, and that's safety, isn't it? It's explainability and safety. Yeah, they're the two things. Because, and the hype train is hurting adoption, because there's all that hype going on out there, right? And it's hard to understand how this technology works. So I actually think the hype train's actually made some decision makers more nervous about making those decisions, right? Yeah, I would say security.
Just to add to that, one of the things we've seen when talking about these things is privacy is huge in that context. I think one of the ways we've got around the competition is to sort of explain between a private and a public model.
Yeah, absolutely. Yeah, that's really good shout actually. So, you know, I didn't mention this at the beginning, but at the very beginning, right? At the very beginning, I know there were some naughty customers putting customer data maybe in ChatGPT, creating things, right? And you know, there was a big misunderstanding about where models are hosted, you know, where that data goes and so on. So just to talk to that for a minute, you know, you've got public services like ChatGPT, right, that you just use, the free subscriptions and stuff like that. That data is being used. It's being used to retrain models. It's the perfect sample set of something called RHLF, I always get that wrong, reinforced human learned feedback. So public models, you wouldn't be using those in business, right? Now, those same public models, so things like ChatGPT, they sit on OpenAI. So you can create private subscriptions of those models in, say, your Azure tenancy, yeah? They have different T's and C's, yeah? They aren't using your data to reinforce and retrain, yeah? You know, you need to be able to really clearly articulate those to the protectors of the realm. And then in the extreme, I say extreme example, because you still may be nervous, right? You may have scenarios where it might be really sensitive IP, where you want to go one step further, and rather than use a shared service that is within your tenancy, but a shared service, you might want to use private models, things like llama models. Who's heard of llama models? Yeah, cool stuff from Meta. Yeah, so you've got those, you've got Quen, Mistral, quite a few actually now open source models. You can run those privately, and you could run those on physical tin in your data center if you still have data centers, or you could run those on private virtual machines, yeah, in Azure. Now, that's super secure because that's your VM, right? And that model's running in your VM, and the data's only going where you let that data go, right? Interesting, actually, another one you made me think, Dave, and Martin. The other thing people got really worried about at the beginning is language models learn as you use them. Yeah, they remember you, right? They do not remember you, right? Language models, the way they work, when you're having a conversation with ChatGPT, it's not remembering you. Notwithstanding it keeping data for training, but the model doesn't remember anything. It remembers nothing. It reads the entire conversation from beginning to end every time. That's how language models work. And that was a big worry at the beginning. Everyone thought they remembered stuff. They don't. When you go back and chat, they're reading it. It's why they get slower as the conversation continues. Right. We're there for time, Nick.
25 minutes left.
Okay. Right. A quick planning example. So this is my incident data set. It's just water incidents, right? And some information on DMZs, which are district metering zones, and some company information, and then some employee profiles. It's a small data set, right? It's just really geared up for a quick demo like this. And this is an interactive demo, because obviously if it was an agentic process running in the background, we wouldn't have anything to look at, and that wouldn't make for a very interesting demo. So sort of imagine this running in the background, yeah? So we'll run a prompt. So we have a massive burst in the Bristol TMZ, which is part of the water company, Makers Clear Water Inc. I obviously created this data set. The residents are panicking and some citizens are upset. The burst is massive, blah, blah, blah. We need to kind of deal with it, right? So we run that. And what it's going to do, and I'm going to show you the system prompts for this, because it may inspire, or at least show you kind of how some of this stuff works behind the scenes. So it's going to go and do some searches around the DMZ and the company. It's going to find some lessons learned as well. It's finding some lessons learned here. Clearing the results again to make sure we keep a lid on the context size, because anything prior to that's redundant now, because we're now looking for experts to help. And we've done the weather check as well, and we're going to build a skills graph as well. I like this. Oh, that looks great. I like that one. It's big telly. What we've done there is we've also called an external tool, weather check, right? So on the fly, we've gone and got the weather. But you could imagine getting telemetry information, right? Or all sorts of stuff from back-end systems on the fly, right? From live data. External joke. But, catch me at lunchtime. Not funny. Stop. Oh, God. Anyway, so you can then use the tool calling to go and get some of that data, external information that perhaps you don't want to index. It always needs to be absolute kind of real time, right? And what we've also done here is we've created a skills graph. Now this is quite cool, right? Because it's built us a graph, who knows about what, right? Tina, Amanda, etc. and why they know about it. It's built on the fly. The language model there has taken all of those results and I've asked it to build me that graph. And then I've used a Go.js visual component to build that graph. I can actually go in and verify these things. If I click on teamwork and communications, there we are. There's the evidential document that underpins that connection, right? Cool. Explainability. And what we've done there is we've built that graph on the fly. Now, it's an interesting one because you've all heard of graph databases as well, right? So graph databases, we actually integrate graph databases, super important, yeah? For hyperscale graph analytics, criminality detection and things like that, you absolutely need to build your graph in advance. Yeah, you need to build your graph in advance. But if you want a graph from a smaller set of data on the fly, just to understand knowledge relationships, you don't want to persist all of those in a graph database, right? Because the question might be different all the time. You can start to think about how you use language models again to start to provide some more structured output. What actually happens here is it actually calls a function, build graph, that build returns a highly structured JSON data set, and then that's spun out into this kind of visualization that you see here, which is quite cool. So that's planning. I'll show you a compliance one over here somewhere, right? So, my OneDrive. So obviously it's a fictitious tiny data set, right? My OneDrive is a mess. My OneDrive's a tip because I just put stuff in there. I don't classify it. I don't organise it, right? And that makes it really hard to find and it means we're not very compliant. So there's my OneDrive. And down the side here, you'll see there's no classifications or organisations attributed to it, right? Let's fix that. So let's choose the OneDrive compliance helper. And let's tidy my OneDrive, please. It's a tip. Simple example, right? But here we go. So it's going to go and pull those back. Here we are. So it's going to go through each one, and it's going to work out what it thinks the classification should be, and it's going to give us the organisation that it belongs to. Now, it's not applied that. It's asked me to check. Right? It's asked me to check first. Point to note, the classifications, you're using a classification model to generate those, right? So they are known labels. There was a lot of hype in the beginning about language models being used to classify documents. It's a bit problematic because language models they create varied output by their very nature, right? They're not deterministic. They rely on probabilities, yeah? So for something like classification, you always want a project plan to be a project plan, yeah? You always want to be an invoice to be an invoice. So that's a good example of where you train classification models to kind of do that. So this uses a combination of both. Anyway, we'll say yes to that. And you can imagine this running in the background, right? But coming back through a notification mechanism to ask you if you want to kind of apply those. But it'll do the heavy lifting for you. Come on, chop chop. There we are. So it's going to apply those now. I'll just talk quite those. I've got 20 of them. But yeah, so you can see how that would be kind of done in the background, but with the right human oversight for you to validate. Yes?
Just in relation to that, inferring permission to do something, it's a question I've had a lot from, so I work for the Cabinet Office, and I'm trying to reassure people across parts of the government that there are guardrails in place and we've thought about all these things. And the one that keeps coming up is, in the case of, say, Gemini, inferring permission to do something from the language model itself. And I wonder if you have any insights as to...
Yeah, so what we do, there isn't a slam dunk answer to that, right? There's not a slam dunk answer. First of all, if you're going to perform actions, you need to give the language model the tools available to perform those actions. I would heed against creating big agentic processes that have access to a myriad of tools, right? Because that gives you a whole host of other problems around tool selection accuracy. But what you want to think about there is guardrailing through your system prompt, putting access control lists on individual tools themselves, right? So that is a real, we did that actually, funnily enough, something we put on our own tool calling the other week, yeah? So you add a layer of security beneath the language model. So actually on a tool definition, if the language model tries to tell you to call it and you are not allowed to execute that, it will blow up. We can't do it. And the other thing as well is when you are performing actions in back-end systems, the other thing to think about as well is checking the access control in the back-end system, obviously. So here is actually, there's a check taking place in the tool that applies the classification that I have right access to that file. Otherwise it won't work, right? So there's a couple of things to kind of think about there. There isn't a magic bullet for that really, and I think, something that we've definitely learned with building agentic processes is think about specific use cases, outcomes that you want to achieve, and what that does is it reduces the number of tools you're using, reduces the data set, and makes those problems more soluble and tractable, right? We've looked a few times with some customers to build like mega chatbots, right? Or, that's just all your data and some tool calls, and that's really not the way to go, right? Because you lose some of that control, and you make enforcement and guardrailing more difficult.
Well, first off, message for your daughter. You've done an amazing job.
I'll tell her that.
and you have a new nickname, Captain AI. Can I just go back to hallucinations? And you were talking about safe and explainable use. And Steve was talking about golden collection.
Yeah.
And I want to add this idea of a reliable source of knowledge.
Yeah.
If I ask Tom O'Farrell for advice on fashion, hallucinate. If I ask him about advice on AI, it's going to be accurate. And one of the things that I've had lots of people say, it's going to hallucinate. It doesn't know when it's not lying. It doesn't know that it's not an expert. But in future user cases, if we are very, very specific about its expertise, its use, and its small,
Yes.
those hallucinations then become considerably less.
Considerably less, yes. There is absolutely no doubt about that. Because you just got to think, I'm not going to, maybe at lunchtime if you come and catch me, but, processing, when you ask a model to answer something or give you a fact, it's looking across trillions of tokens and relationships and probabilistic connections between tokens, massive amounts. It's truly a mind-blowing amount of information they're trained on. When you give that model a small subset of information, you've guardrailed it in. One thing I will say, so hallucination definitely dramatically decreases with retrieval augmented generation, and you have the backstop of being able to look at those facts, which is what you've seen me doing, right? Looking at those and verifying those. It's super important, yeah? The one observation I have made, though, and this tends to happen with increasing context sizes, is they can be a little bit forgetful, which is a subtly different problem, yeah, but to hallucination. Yeah, so you might say, I don't know, what are all the invoice numbers in this data set? And there's 30, and it gives you 29, right? That's an extreme example. That wouldn't happen. You need to give them thousands, right? But sometimes you can kind of see that happen.
It's the screen's gone, I think.
Oh,
Liz can't fix it.
oh, okay, not me. Yeah, got this far without any major faux pas. Remarkable, Paul. Yeah. Let's just do that while we do that. Yeah, so they can be, but, again, self-attention, that forgetfulness, if you give him more data than you need to give, so again, you're shrinking the world down, right? And it's a conflict, isn't it? On one hand, you want every bit of data indexed. On the other hand, at the right point in time, you want to be able to, provide a smaller data set. Another bit of advice there actually as well when building solutions, be very clear with the user around the data they've actually got that's underpinning that answer. Because if you've only given the model 30 invoices, and you've not made that clear, the users, well, that's not right, because I expected 60. No, we've only given it kind of 30. So that's a UX, user experience thing. It's interesting, the user journey thing, actually. Changing, I mentioned earlier the changing role of user interface and us building less UI. It's shifting our thinking and shifting the UI effort into, how do we, that whole journey of using the AI, confident use and stuff. But yeah, it's a good, pretty cool.
Well, it could be a question under the hype label. But last year we had the Chinese releasing DeepSeek into the world, which at face value offers less horsepower to build foundational models. I just wondered your view on that, whether that was going to change our strategy for how we invest in
Yeah, so I think one of the biggest innovations with DeepSeek, so I won't comment on the cost to build the model. I'll just leave that there, how much they spend building that model and the chipsets they use, that is not completely clear. What I will instead comment, and this might kind of answer it, I think it answers the question because they did take a novel approach. And the approach they took was something called mixture of experts. Yeah? So if we think about language models, if we think about GPT-4, that language model contains stuff about writing Python code, things about diagnosis of cold and flu. It has information in there about farming, all sorts, right? There's lots of different domains of information. And when you use a model like that, it activates all of the parameters to answer the question. So it's considering Python code over there and all sorts of things to answer your question. What Mixture of Experts did was take an approach to almost think of the model and then think of sets in the model of tokens. And those smaller sets get activated dependent on the classification of the prompt. Right, so if you're asking, generate me a web scraper in Python, it only activates the tokens around there. And that's why it's significantly faster and significantly cheaper. Because the cost of running models really largely comes down to the amount of GPU memory and infrastructure that's required to run those models and run those prompts. So that was the big change, Mixture of Experts, really. Be interesting to see how other vendors, whether they follow suit and where that goes, right? Sorry? Go on, you Gemini, yeah?
Gemini, Mixture of Experts.
Yeah, Gemini, yeah, I guess, you've got Gemini, yeah. So.
How's best to tackle industry-specific terminology and even sometimes cultural-specific terminology, especially in sort of scientific areas?
Yeah, so from an information retrieval perspective, right, so if we think about retrieval augmented generation for the minute, retrieval augmented generation, you're going to want that search step at the beginning. So you need to first of all think industry terminology, right? That's going to be manifest in your query and it's going to pull information back. You might need to think about synonyms and things like that, especially if you're multinational, global, or you've got different ways or acquisitions and you describe things differently. So things like synonyms. I mentioned earlier things like, well, I didn't mention, but the algorithms like the splayed algorithm, which is particularly good at vocabulary mismatch. You might want to do some transfer or fine-tuning of those search steps, which is different from fine-tuning a language model, but you can kind of think about that. In terms of then fine-tuning large language models, it's a big decision if you're going to go down that route, right? If you're going to go down that route. Primarily because of the data curation and data preparation and data quality steps that need to be put in place to fine-tune models. What we tend to observe, and I can speak from experience, right? Because you're passing that information to the model that has all of your industry-specific terminology in, the language models are smart enough to work it out. That's absolutely what we observe. And we've got two really good examples of that. It's broken again. Anyway, so we tend to see, we've got some customers where there's highly domain-specific information and all of the responses we get back, because it works out on the probabilistic connections between those tokens and understands language. So it is an example of what language models really bring to the table. and that is understanding language. Right? The knowledge is a bit of a byproduct. But you could go down the route also of fine-tuning models potentially. Yeah, but as I say, you need to really think about whether you need to do that and the business case behind it. And you definitely want, the generalised models, they do perform remarkably well on corporate information, which by its very nature is domain specific. 10 minutes if anyone's got any more questions.
I have an observation. So, points you made, one that volume of data does not solve the issue of the quality of data,
No.
considering hallucination. And the second point, the cost of training models. Now, for those who follow what is happening on the continent with the strategy for AI development, they just published a strategy where point number one is to build huge IT infrastructure and give it to the public, I would imagine small and medium enterprises, to train the models, which I assume to lower the cost of training, and then train it on so-called common data space where they want to pull data from health sector, finance sector, agriculture, energy, and so on. But if that will not be of a quality, then is the success of that going to be diminished, or still the volume of data would compensate the result?
I think it's not an easy answer to this one. If you can absolutely ensure data quality, and you can prepare the data for successful fine-tuning, because as I mentioned at the beginning, training models, you've got this initial exercise in training a foundational model, and that's the objective of that is that it understands language, right? I'd be interested to see if people start building, you've got Gemini, you've got Google, you've got Llama, you've got a couple of 4 or 5 big players building foundational models. It's hugely expensive, astronomically expensive, right? I suspect where this will go is that you probably take those base models, you're not going to try and do that, but then perhaps build domain-specific models for industry on top. And I suspect the success of it will come down to data quality, and it will come down to the data preparation as well. And that's a big the cost shifts. Training base models is actually very low, like human labour. They're in fact they're called self-supervised training, right? Some clever people at Google worked out that you could just take loads of information on the internet, blank random words out and give them as the answer, and then, hey presto, you can train a model to predict the missing words. It's called self-supervised. It was the breakthrough along with self-attention, or one of the breakthroughs, right? But that fine-tuning piece, you've got a lot of human effort to prepare the data into valid training data, and obviously use a lot of IT tools to help with that, but you've still got to do that. And then you've got reinforced human learned feedback as well, where you go through a process of using humans to positively score correct and incorrect answers. It's how we weed bias and toxic content out and things like that. It's going to be really fascinating to see. But still, are we going to have a set of industry-specific models that organisations can then pay for or take and use themselves? I think the question is, are organisations themselves going to go and fine-tune these models?
Which then may become responsibilities for organisations to make sure they have good quality of
100%, yeah.
They push the data into the common space.
Yeah, 100%. And I think, for the foreseeable, as I mentioned earlier, hallucination is manifest in the way the technology works. You're never going to fully eliminate it. Not anytime soon. There's a lot of very clever people trying to work that out, but they are token prediction engines. They use weights and they predict, so they can predict incorrectness. Yeah. So that advantage of having sort of your content alongside the answer does give you a way of that kind of verification, right? But hallucination, that there's no doubt that will improve anyway as well. So it's all part of that journey. But yeah,
really awesome presentation. Just interested in reflections, because obviously a lot of what we focus on is unstructured data.
Yeah.
Models are trained on primarily unstructured data as well. Interested in any reflections you're seeing around when you then come to integrate structured data?
That's a brilliant question. I'm so pleased about that question. language models are actually really good now with structured data. Yeah, you need to think about the format of that structured data, but they're extremely good at processing XML and JSON data. And that is, you've only got to look to function calling as the best example of that. The actual output it produces is JSON, right? If you're interested, I can show you at lunchtime. But yeah, they've got much, much better. But you do need to think about, obviously, data quality. That goes without saying. That is an overarching theme of the day. Yeah, they are really good as long as you prepare that data and you pass it in a uniform way, especially if there are lots of rows, but it will do a very good, it actually does quite a brilliant job actually of passing and doing that. I can show you some examples actually of that in action as well. I don't know anything else. It's going on like everyone in the audience.
One more.
Yeah, sure.
Continuing that topic around structured data. So when it comes to questions based on structured data, there's the what, there's the language models are fairly good at calling a particular function, creating a table. The why is usually the next question, especially from a business user. Okay, my sales went down 5% by this in this region, in this channel, etc. Why? Was it the weather, which is the usual culprit to blame, or something else?
It's a complex question, and it's a really good question, right? Because it is that follow-on question. If you've set up your tool calling correctly and the right data sources are available, it can access that. You could get it to go and access that information, right? But here's one of the challenges with language models. Some of those whys would involve numeric calculations, wouldn't they? That's a good question, right? It's a really good question because language models are token prediction engines. They predict tokens. Why would you use a token prediction engine when you've got a calculator? Why would you do that? You'll get a little bit, you'll think, but Paul, I saw on LinkedIn it solved this maths equation, right? Algebraic equation. Slightly different challenge, isn't it? Solving an algebraic equation could be solved by predicting tokens, because you've learned those, what they look like elsewhere. Actually adding up, yeah, you can go and add up some short number sequences, but go and give a language model 500 or 1,000 invoice totals. I don't know, there's hundreds of thousands with some decimals. You won't get it right. And why would you do that anyway? Use a calculator. So where I'm going with it is think about data descriptions. You can then bake in data functions that return real data and do real aggregations. And we've actually built a solution for a customer that does that very thing. It takes natural language, it goes and finds proposals in this case, but then it uses database calls to perform aggregations to work out the total line item costs and what have you. So what comes back is fact, is numerical fact from aggregations on proper databases, yeah? So again, contrary to what you might be seeing on LinkedIn, there is a place definitely for calculators and databases and all of your existing kind of, your structured data repositories, right, that do those things so well. We're not throwing the baby out with the bathwater anytime soon. Hope that goes some way to answer.